Hello friends, we will see how to solve minimization LPP using simplex method. So we will go straight to the problem. So we will take this sum. Min z is equal to 16x1 plus 16x2 subject to 2x1 plus 4x2 greater than or equal to 3, 3x1 plus 2x2 greater than or equal to 4, where x1 and x2 greater than or equal to 0. So first step is you have to see what is your objective. Your objective is minimization. So if it is a minimization problem, you have to see whether the constraints are in tune with the objective function. That's your first step. Whether your constraints are in tune with the objective function. So if it is a minimization problem, you must have at least one constraint greater than or equal to. So you know that in this question, both the constraints are greater than or equal to. Therefore, the constraints are in tune with the objective function. In case if you had less than or equal to, then you have to multiply the entire constraint by -1 to convert less than or equal to greater than or equal to. Right? So the first step, we are checking whether the constraints are in tune with the objective function. They are in tune with the objective function. The second one is the revised model. So when you do the revised objective function, revised objective function. So what is your first constraint? I'll write here min z is equal to 16x1 plus 16x2, and you will add whatever the variables that you are introducing that needs to be incorporated here. Next one, subject to, the first constraint is 2x1 plus 4x2. Now, since it is greater than or equal to, that means your left hand side can be greater. So if it is greater, to make it equal, something has to be subtracted. So I will subtract S1. So this S1 is a surplus variable. And whenever you introduce a surplus variable, along with that, you need to introduce an artificial variable. This is because you cannot use surplus variable in your program variables in the initial simplex table, because the coefficient is -1 and it will not form a unit matrix when you're solving in the simplex table. So always remember, whenever you introduce a surplus variable should be followed by an artificial variable. So why are we introducing a surplus variable? Because of greater than or equal to sign. And I know here S1 is a surplus variable and A1 is an artificial variable. Artificial variable. Okay. Now, second constraint, again, it is greater than or equal to. So 3x1 plus 2x2 minus s2 plus a2 is equal to 4. Again, here I'm using a surplus variable because it's a surplus variable. That's why I'm introducing a surplus variable followed by an artificial variable. So here s2 is a surplus variable and A2 is an artificial variable. Artificial variable where x1, x2, s1, s2, a1 and a2 greater than or equal to 0. Now you have to modify your objective function. So you said revised objective function. So since you have introduced the surplus variables and the artificial variable, you have to modify this. Now surplus variables will produce zero profits because this is the excess raw materials that you have used. Okay, so it'll be 0s1 plus 0s2, and the artificial variable, the coefficient in the objective function would be depends on your objective. If it is minimization, it will be plus m. That means the highest penalty cost. And as far as possible, we should not have, we should try to eliminate this artificial variable from the table. Therefore, it is plus MA1 plus MA2. So this is the highest penalty cost. Supposing if it was maximization problem, I would have written here minus MA1 minus MA2. Minimization, it will be plus A1 and plus MA1 and plus MA2. So now the second step is over. That is, we've already formed the revised objective function and we revise the model. Now we can prepare the initial simplex table. So the first initial simplex table, the format, first is FR, program variables. Now here, I won't write profit, I will write cost. Because it is maximization problem, minimization problem. So it should be cost. So cost to minimize. If it was profit, it is maximization problem. So I will write here program variables, cost, quantity, x1 and x2. These are the basic variables. These are the basic variables. And these two are the surplus variables. And these two are artificial variables. Artificial variables. Okay, now how to start filling up the table. So the first one, program variables. Remember, from each constraint, you have to take one variable. So the first constraint, you know that you cannot start with a surplus variable. You must always take artificial variable. So artificial variable is A1 for the first constraint and A2 for the second constraint. So I'll write here A1 and A2. And what is the cost? Cost is M, and here also M. Now, what is the quantity? Quantity is the right-hand side value of the constraint. So it is 3 here and 4. So I'm going to write here 3 and 4. Okay, now we will fill in the coefficients of these variables from the constraints. So x1 coefficient is 2, x2 coefficient is 4. For S1, it is -1. A1, it is +1. So it is, they are what? 2, 2, 4, -1, and there is no S2. A1 is 1, and this is 0. You have A1, you don't have S2, you don't have A2 in the first constraint, therefore it will be 0. Now see the second constraint. It's 3, 2. For S1, it'll be 0. For S2, it'll be -1. No A1, it'll be A2. So it is 3, 3, 2, 0, 1, -1, 0, and 1. Now, please check at this point. You have taken the program variables A1 and A2. So A1 and A2, these two should form unit matrix. That is 1, 0, 0, 1. Now copy the objectives, coefficients from the objective function. Coefficients are from the objective function 16, 16, 0, 0, m and n. So I'll write here 16, 16, 0, 0, m and m. So these are the coefficients from the objective function. Now, how do I compute the C value? You know that this one, whatever you have here, this column into this. So it will be m into 2 plus m into 3. So m into 2 is 2m and m into 3 will be 3m. So 2m plus 3m is equal to 5m. So I will write here it is 5m. Now the second one. So this is over. This is over. Now I'm going to multiply this. So it'll be 4 into m or m into 4 plus m into 2 will give you 4 into m is 4m plus 2 into m is 2m. So you get 6m. Next, m into minus 1 is minus m. 0 into m is 0. So here you will get minus m. And what is this? This will be m into 0 is 0. M into minus m is minus m. You will get minus m. M into 0, 1 is m. M into 0 is 0. So it is m plus 0 is m. And here also m into 0 is 0. M into 1 is m. So this is m. Now, what is net evaluation row? We know that net evaluation row is z minus c. Now, what is z? Z is 16. 16 minus 5m. So I'll write here 16 minus 5m. And here it is 16 minus 6m and 0 minus m minus m, because you are subtracting, it will become 0 minus m will become plus m. This is 0 minus m because you're subtracting, minus will be, you have to change the sign, so it will become m. M minus m will give you 0 and m minus m is equal to 0. Now we have got this 16 minus 5m, 16 minus 6m, and m 0 and 0. Now for a maximization objective, we will select the one which gives you the highest value. Now here you will have to choose the one which gives you the least. Now, what is the least here? Least is 16 minus 6m because 6m is the highest cost. From 16, you're minusing 6 times the highest cost, whereas here it is 16 minus 5 times. So this is the least. Therefore, this will be selected as the key column. So I'm going to select this as the key column. So this is the key column. Now, how do I find out RR? RR means the replacement ratio. So in the decision is, because you have, this is the key column. So this variable that is x2, you have to produce, this will enter the table. Now to enter it, to bring this x2 in the table, one variable has to go out. Is it A1 or is it A2? How to determine that? You have to find out the replacement ratio, that is RR. What is RR? It is the quantity divided by the key column element. Quantity divided by key column element. You have 3 over 4 and 2. So 3 over 4 and 2. So 3 over 4 is 0.75 and this is 2. You have to select the one which is lower. The lower value is 3 over 4. So this will be the key row. And you know that where the intersection of the key row and the key column, you have to select this and you have to call this as the pivot element. This is PE. This is pivot element. So X2 has to come enter the table, and which variable has to go out? It is A1. A1 has to leave the table. So that's the decision. And you know that for the key row, their fixed ratio is not applicable. For the non-key row, what should you do? It is the key column element divided by the pivot element. Key column element divided by the pivot element. So how do I get this? It is key column element divided by the pivot element, which is 4 divided by 2. 4 divided by 2. So the first table is done. Okay, so you know that A1 has to leave the table. So this A1 has to go out of the table. That means from the second table onwards, A1 should not be there. So remember, once an artificial variable goes out, it should not re-enter the table at a later point of time. So in the next table, when you are preparing the second table, you will cancel out this A. So A will not and will not be there. This column will not be there. So you can leave this column blank or you can just cancel it out. It should not re-enter the table. That A1 should not re-enter the table because it's an artificial variable. So now I told you the order of the variables you cannot change. So it should be A1 and A2, but A1 will go out and in its place it should be X2. So A1 should leave the table because A1 should go out, and in its place I should have A2. I should have X2. So what is X2? X2, what is the cost? X2 cost is 16 and A2 cost is M. So you know that M, you have to take it from the objective function. So 16 and this is M. And how do I fill in the program variable? The first row, that is the key row elements. How do I prepare? How do I calculate? It will be go to the previous table, take the corresponding element. Go to the previous table, take the existing value, divide this by the pivot element, which is 4. So I repeat, how did I get this? It is the existing element divided by the pivot element. So go to the previous table, see what is existing, that divided by 4. Similarly, I'll do calculate for the others. You need not calculate for A1 because A1 is an artificial variable. An artificial variable, once it leaves the table, it should not re-enter. So this is over. Now coming to the second one. How do I calculate the second row? In other words, the non-key row. How do I calculate the non-key row? Go to the previous table, see what is the existing element. So that minus, open the bracket, and you take the key row element multiplied by the fixed ratio, which is 1 over 2. So I repeat again, how did I get this? How did I get this? Go to the previous table. Previous table, it's 4. Minus, open the bracket. In the key row, the element is 3. This multiplied by the fixed ratio, which is 1 over 2. So this is what you need to do for, you have to calculate for all the other cells. So I'm doing it. So here also I've calculated. And you know, Z values will not change. Z values will not change because they are from the objective function. And this is M, capital M. Okay, so this is filled in. Now we have to compute what is C. How do I compute C? So how do I compute C? It'll be 16 into, remember, it is this, that cost. This into the variables that you have here. So 16 into 1 by 2. So 16 into 1 by 2 is 8. 8 plus 2m, because 2 into m is 2m. So 16 into 1 by 2 will be 8. 8 plus 2m. So I get 8 plus 2m. That is the value you get in the for the first thing. Now the second one is 16 into 1 is 16. M into 0 is 0. So I get here 16. The next one, 16 into minus 1 by 4 will give you minus 4. Minus 4 plus m over 2. So minus 4 plus m over 2. This is what you get. The next one is 16 into 0 is 0, m into minus 1 is minus m, so 0 minus m is minus m only, and 0 into 16 into 0 is 0, m into 1 is m, so you get m. Now, when you calculate what is the net evaluation row, that is C minus Z minus C. So when you minus it, remember it is 16 minus this value. So 16 minus 8 will be 8 and minus 2m, because it is, I'll write it here, 16 minus 8 plus 2m. So when you change the sign, 16 minus 8 minus 2m. So 16 minus 8 is 8 minus 2m is the value you get. And 16 minus 16 is 0. And this will be 4 minus m over 2, because 0 minus of minus will become plus, and minus into plus will become minus. So plus 4 minus m over 2. And here 0 minus of minus m will give you m. And this will be m minus m is 0. Now you can make one cross check here. NER value, whether it is right or wrong. One small cross check would be, this is x2. So see the x2 column NER value should be 0. A2 column should also be 0, because you have taken, these are the program variables. For the program variables, NER value should be 0. Similarly, you can see in the previous table also, you have taken A1 and A2. A1 column NER value should be 0. A2 column NER value should be 0. Now, you have to decide which is the key row and key column we have to identify. Now, how do I identify? Because this is minimization problem. You will see which is the least value. Which is the least value I have to compute here, least NER value. So here it is 8 minus 2m, and this is 4 minus m by 2. This is half m. You're subtracting half m, and this is minus 2m. So this is the 8 minus 2m is the least value. So I will take this. This is the least. So this will be the key column, because here it is 4 minus half of m. Here it is 8 minus 2 times m. Okay. So I have to identify which one is the key column. I've identified the key column. So this will enter the table. So I'll put this in one box. So this is the key column. So key column element will enter the table. Now, when x1 enters the table, some variable has to leave. It could be x2 or it could be a2. I don't know which one. So to determine that, I have to calculate the replacement ratio, that is RR. How do I calculate the replacement ratio? It is the quantity divided by the key column element. Quantity divided by the key column element. So I get 1 by 2, in other words 1.5, and here it is 1.25. So this is 1.5 and this is 1.25. So 1.5 and 1/4. Therefore, 1/4 is lower than 1 by 2. Therefore, this will be chosen as the key row, the lower value. So now I will put this in one box. I will put this in one box, and I will also find out what is the intersection. The intersection is the pivot element. So I will put this in one box and call this as the pivot element PE. As you know, for the key row, fixed ratio is not applicable. For the non-key row, um, the it will be the whatever the element that you have corresponding to this key column element, divide that by the pivot element. So it is key column element divided by the pivot element, which is 2. So you get the fixed ratio as 1/4. Now, which variable has to leave the table? You know, it is A2, because this is the key, not key column, sorry. This is key row. This is key row, and this element, that is A2, should leave the table. And as I told you, since it is an artificial variable, once an artificial variable leaves the table, it should not re-enter the table. So next time when you are preparing the table, you must ensure that these two variables, there won't be any values. So this you need to cancel it out. It should not come. You need not do any calculation for these two because both the variables, artificial variables, have left the table. So when you do the next one, x2 will come first. And in place of a2, I have to write x1. I repeat, you cannot change the order. Here it is x2. So first element should be here x2. And here in place of a2, x1 should come in. So you must write x1. Now, what are the cost? It is 16 and 16. They are coefficients from the objective function. So 16 and 16. Now, which is the key row? The second row is the key row. So how to fill in the key row? Go to your previous table, see what is the element that divided by the pivot element. I repeat, go to the previous table, see what is the existing element, divide this by the pivot element. So in this case, it is 5 over 2, divide this by 2. You will get 1 by 4. Similarly, you have to calculate for all the other variables. Other cells, you have to calculate the values. Now, coming to the non-key row. Non-key row, go to the see what is the existing value minus, open the bracket. It is the key column element, key row element into the fixed ratio, which is 1 over 4. So I repeat, how did I get this? It is 3 over 4. What you have in the previous table, from this you need to minus what? The key row element. What is the key row element? It is 2, 1 by 2 into the fixed ratio, which is 1 by 4. So this is how you get the values. So this I'll have to copy paste. So I have to calculate for all the other uh, values for the other table. Now, Z values, there is no change. It will be 16, 16, 0, and 0. For C, that is the computed value. How do I calculate the computed value? It is the cost which you have here. This is the cost. This should be multiplied with this. So it'll be 16 into 0 plus 16 into 1. So I'll write here, it is 0 into 16 plus 1 into 16. So this is what you need to do for all the other cells. I repeat, for the second one, what will it be? It'll be 16 into 1 plus 16 into 0. The third one will be 16 into minus 3 over 8 plus 16 into 1 by 4. Now I will calculate what is the net evaluation row, that is C, Z minus C. I get 0, 0, 2, and 4. Now you have to, because it is a minimization problem, you have got all the values, NER values 0 or greater than 0. You don't have any negative value. Do you understand? So that means you have reached the optimal solution. So this is the optimal solution. You have already reached the optimal solution. Since all NER greater than or equal to 0, for a minimization objective, this is the optimal simplex table. Hence, the solution is taken from the quantity column. So what is the quantity column? X1 should be 5 over 4. That is 1 by 4. And x2 should be 1 over 8. And when you substitute those values in the objective function, you will get 22. So this is how you solve minimization problem under simplex method. Hope you have understood. Okay, thank you very much.